Your body creates by weight the same amount of ATP molecules a day as you weigh. If you put all the molecules of ATP you made today on a scale, it would weigh about as much as you, depending on what you did that day. Your body achieves this by recycling adenosine diphosphate and adenosine monophosphate back into ATP, adenosine triphosphate, which your body uses for energy. But what if your body became much less efficient at creating ATP? Well, that's exactly what happened to factory workers in World War I. In World War I, the US government employed millions of female workers in bomb-making factories. There weren't many regulations back then, so these women ended up being accidentally exposed to a molecule called DNP, or dinitrophenol. The workers that breathed these compounds in experienced a sudden, unexplained weight loss, which is usually a really bad sign by the way, but the doctors of the time found nothing wrong with them. So scientists were able to synthesize this DNP molecule on its own, and they found that it was able to increase your metabolism by an incredible amount. Basically, you'd be burning much more energy in the background than you already were. So how did it work? Well, to explain, you have to know some basics about how ATP is made in your mitochondria. Inside the mitochondria, there's an inner and an outer membrane. The outer membrane has a lot of hydrogen ions, which are really just protons, giving the outer membrane a positive charge. The inner membrane has lots of electrons, giving it a negative charge. The protein really wants to have electrons, but there's a barrier between the two membranes. The protons can't get through the barrier except with the help of a protein called ATP synthase, which exists on the wall between the two membranes. This protein is basically a tiny hole that the proton has to go through. So you can think of the outer membrane as a water pressure buildup, and the ATP synthase molecule as a hole in the dam that shoots the water through, except instead of water, it's a buildup of protons. When these protons get shot through the ATP synthase hole, their fast movement across this barrier supplies energy that converts ADP to ATP. In fact, it only takes 30 seconds of this process not working for you to die. Cyanide, for example, blocks this ATP synthase molecule from receiving oxygen, which is why cyanide kills so quickly. So, this DNP molecule works by breaking through that mitochondrial wall, leading to not all the protons being used to create ATP. So your body uses all the chemical energy from the food you eat to supply these protons, just for DNP to make a hole in the mitochondrial wall, which makes these protons go to waste. This means your body has to use more stored energy to supply more protons to make up for all the energy that went to waste. In addition, your body would also create more mitochondria, which would also use more of your body's stored energy, causing you to lose more weight. Because of this, DNP became one of the best-selling drugs of the 1920s and 30s. The diabetes drug metformin, which by all accounts is a miracle drug, works in a similar way. By blocking mitochondria from creating energy, it forces your body to make more mitochondria, leading to not only weight loss but reduced insulin sensitivity, helping to put their diabetes into remission. The problem with DNP is when you bust through that membrane, it creates a byproduct of heat. People took too much because they wanted to get thin quickly, and these people actually overheated and died of heat stroke, which interestingly enough led to the creation of the FDA, the MFDA. The drug was deemed unfit for human consumption by the FDA that was created because of it, and it was completely banned in the US by 1938. However, you can still get it on the black market or in Russia if you really want it. In fact, Russian soldiers were given DNP during the winters of World War II to help them keep warm during the war, which is how I learned of the drug in the first place. Anyways, thanks for watching. Bye everybody.
This is a tough hurricane, one of the wettest we've ever seen from the standpoint of water.